Hey guys, a couple more examples from 6-1 standard normal distribution. Okay, again, wanted to make sure that we realize that this is our density curve. Down the middle, there is symmetry on both sides. The total area under the curve is equal to 1. This area is represented as the probability. This is my axis, my line. Right in the middle, mu is equal to 0. The z-score is equal to 0. The probability is equal to 0.5. And I've put 3 extra zeros in there because our probabilities on table A2 are 4 digits. To the left of center, negative z-scores and probabilities that are less than 0.5. And to the right are positive z-scores with a probability greater than 0.5. And for our standard normal distribution, we're looking at mu equals 0 and sigma equals 1. We read, and the way the tables list it with the answers, we read from left to a right vertical boundary. From left to a right vertical boundary. Okay, so with that brief review, don't mind, let's look at a couple of problems here. So these problems, what we have here, they've given us the area and they want to know a z-score. This one here, probably a little hard to see, but here's my given area, 0.9418. I need to look up that area on my table and find the corresponding z-score. So whenever I look at that, if I just see this area and I don't see this, I know that that's going to be a positive z-score because it's closer to 1. All right. If I have this, just common sense, right here, this is z equals 0. I'm going to the right of it. So I know I have a positive z-score. And what I'm looking up, I'm looking at these numbers here in the middle. And I'm going to be closer, I'm going to be further away from 0 with my z-score. And the value I'm looking up again is 9418. So I will look through here and let's see. Here's our 94s. And they were decreasing, so here, or increasing, so up here, there we go, 0.9418. So I'll go over, I say 1.5, 1.57. 1.57 is my corresponding z-score for this one. Z equals 1.57. Here I have a given probability, area under the curve, and I'll write it out just in case, 0.0430. This one is going to be a negative z-score. It's to the left of z equals 0, and my probability is less than 0.5. So I'm going to look up in my negative z-scores for 0.430. 0.430. So 0.43. This one isn't listed. 0.436 and 0.427. It falls in between these two. So 0.4. Okay, so this is what I have. I have a z-score of 0.436. Nope. 0.0436. And then 0.0427. I need to determine which is closer. How I do that, I find the difference between them. Okay, this one here is, let's see, I'm getting in trouble by doing it in my head. This is 6 thousandths away, and this one here is 3 thousandths away. Tens, hundreds, thousands, 10,000, sorry, 6 10,000ths, and this one is 3 10,000ths away. This one is the closer representation. Okay, so and let's look at the corresponding z-score for that. 0.0427. That will be a negative 1.72. That's my z-score for it. So to go back to this, these values right here are calculated. But see, the z-scores don't just go to two decimal places. You see down here, and we'll use these, especially in later chapters, I have 3 digits. Well, whenever I use technology to calculate, I get a more precise answer, and I can find a lot, especially looking up z-scores, I can find, using probability or area, a wider variety using technology. They only have certain ones listed here. Kind of saw the same thing whenever we used table A1 for our binomial distributions. So with that, whenever you have one that is not listed in there, you have to compare and find the probability that it's closest to. And all you do is subtract. And this is distance, so my values are an absolute value. It's always a positive answer. Select the one that has the smaller difference, and in this case it was 0.0427. That is the z-score, or that is the probability I used to find the z-score. Alright guys, keep working hard, watch the publisher's videos, read your textbooks, critically think and structure your homework, reason through, and good luck on your remaining homework.